So now what I'm going to do is I'm going to demonstrate the calculation of the covariance and correlation, and with an Excel table that we had created in one of our earlier classes. So we have a table here which gives us the closing prices of 3 different stocks, and I chose this as Netflix, Tesla, and Royal Caribbean Cruises, which is a stock most dramatically affected by the pandemic. And the starting date is 18th of November 2019, and the finishing date is 13th of November 2020. Okay, and when we have these 3 stocks and we actually tabulate them with a time series graph, and we see the following, we see this. So we see the movement of, let me get this here. The blue one is Netflix, and the red one is Tesla, and the green one is RCL, and the green one actually has a very dramatic steep drop here. It drops from 120 to approximately somewhere in the 20s, then it rebounds. So let's see if we want to calculate, I'm going to get rid of this now. If we want to calculate the correlations, what could we do? The first thing, to be convenient, I'm going to just give them some range names. Okay, so starting with this, I'm going to give it this name, starting with the other. I'm going to give it a name again. And starting with the final one, for convenience, in order to refer to them in a convenient fashion, I give them names. And finally, I'm going to give a name for the whole, for the 3 of them combined. Okay, so let's just call that stocks. Okay, so now in order to calculate the covariance, let's start with Netflix and Tesla first. Now I want to have the average of Netflix. Okay, and since I gave a name, I can easily do it like this. The average closing price for Netflix being 423. Then I can do this for Tesla, and since I gave it a range name, I can easily calculate it like this, 224. So what I have to do now is to calculate the differences between the values and the mean. Sorry about that. So differences between each value and the mean. And here I will do this trick which I've done before, and I will need to put dollar signs around that cell containing the average, because when I paste it down, I don't want that value to change. So the dollar signs, which is invoked by F4 function key F4, it keeps that as a stable value. So the difference below the mean by 120. And I'm going to have to do the same thing for the next one. Fix it using the F4 key. Okay. So basically now, if I paste it down, all the way down, so I have now differences from the means side by side. One thing you can notice is these are mostly positive, and at some point they are negative, and there are some mixed values, plus and minus. So what I'm going to do to calculate the covariance is basically to just use a sum product function which sums the products in one array. Okay, and the other. Now that could be faster if I could just It's faster now. Okay, so now it's going to be, I guess it's going to be a positive value, and it's going to be a large positive value. So, and of course, I need to finalize this by dividing it by the number of values, 251 here, 251 minus 1, which is 250. So that is the covariance calculated between the stocks, Netflix and Tesla, and that's a positive covariance. So if I want to convert that to correlation, so this is the covariance, and let me put it like this, okay. Now if I want to calculate the correlation, basically what I have to do is I have to take that value and divide it by standard deviation, and I'll use the standard deviation for the sample formula of Netflix multiplied by standard deviation of Tesla, closing the parentheses. Now that is the value which is standardized now. It's a value that must be between -1 and +1. Okay, and that is the correlation. And I'm using the standard deviation function. So, but there is a function which is already available to us. So let's also demonstrate that. So we have a covariance function, covariance.s. Okay, and if we could just type in the arrays, and now that gives us exactly the same value, covariance s function. We also have a correl function, and if we could just put, the order doesn't matter, of course, and we get exactly the same value. So one way of doing it, calculating the differences from the mean using sumproduct and dividing by the standard deviations multiplied. Using the function covariance and correlation. Now, a third way I'm going to show you is by using the add-ins, the data analysis toolpak of Excel, which I will just invoke from data analysis under data. And I'm going to choose first covariance. And since I have already named the range as stocks, including the labels, I could just use that name. Otherwise, you can also give it, refer to the cells using the cell references. Now, if I say OK, now I get a different format. Now, because I have 3 stocks, I can talk about 3 different combinations. Netflix by itself, this is the variance of Netflix, variance of Tesla, and variance of RCL if you pay attention to the diagonal. The covariance between Tesla and Netflix, RCL and Netflix, which is now minus, so they're actually moving in opposite directions. RCL and Tesla, okay? So these are the 3 covariances which we calculate. And so RCL actually correlates negatively. So let's also get the correlations now, again with data analysis. And since I have the name, stocks, now you see the diagonal, and this triangular format is the same no matter what software you use. It's the correlation of the variable with itself, which is 1. There's a strong positive correlation with Netflix and Tesla and Netflix, a negative one with RCL and Netflix, minus 0.54, and again, a negative correlation with RCL and Tesla, minus 0.32. So that was the demonstration using the covariance and correlation functions of Excel and also the data analysis toolpak. So